Hello, and thank you for joining me today as we continue our discussion on the periodic table. Today we're going to learn about different families and as well as differentiate between what are called metals and nonmetals and the properties that make them up. So let's get started. So here's your objectives. We're going to identify important families of elements, which is what we kind of started on the last uh, lecture video. So we're going to kind of pick that up and finish that off. And then we're going to finish with talking about metals and nonmetals and how those are different in terms of their properties. And so to start with, one of the groups we ended with on the last video was the alkaline metals. So alkaline metals are found in group 1, so the very first column on the periodic table. And these are very soft metals. They react violently with water. And when they do so, they produce hydrogen gas. So they bubble when placed into water, and those bubbles are hydrogen gas. So if you stuck a flame over top of it, you would see fire. And because they are highly reactive with water, they're never found in their elemental state in nature. So both water and they react with oxygen really well. They oxidize. But because they are so reactive, they are never found alone. And the reason they're reactive is because all of them have one valence electron. And so the goal for atoms is to fill their outer shell, fill their s&p orbitals. And so they want to either go up to 8, which is s plus p, which is 2 plus 6 equals 8, or they want to go down to 0, which removes that energy level, which leaves the one below it full. And so because there's only one valence electron, it's very easy to get rid of that one, which then makes them stable. Hydrogen is a special alkali metal because it's not a metal. So this is the only gas in column 1. It has properties very similar to those of other nonmetals, but because it has only one valence electron, they put it in column 1 as an alkali metal. The hydrogen is unique is because it's in column 1, it has one valence electron. Because in the first energy level, its principal quantum number is 1, it only has an s orbital. And if you think back, your s orbital only has one shell, which can hold 2 electrons. So hydrogen can actually gain an electron, or it can lose an electron to become stable. If it bonds to a nonmetal, it loses the electron. If it bonds to a metal, loses electron. If it bonds to a metal, it gains electron. So hydrogen bonds to these. A nonmetal loses the electron, bonds to a metal, it gains the electron. And it's the only element that can both lose and gain electrons to become stable. Our second group are known as the alkaline earth metals. So these elements are found in the Earth's crust, a lot of them, but they are slightly less chemically reactive because they have 2 valence electrons as opposed to only 1. But they react quite readily with oxygen. So in nature, in air, they form a coating that protects the rest of the substance from reacting. So this coating is formed when it reacts with oxygen, forming an oxide, and prevents further reaction. Calcium is the most abundant metal in the body, found in bones and teeth. It's one of the alkaline earth metals as well. We're going to skip the transition metals. We'll go back to those. The group 13 is known as the boron family. This group's kind of unique. That boron is a nonmetal, but the rest of the group is all metals. They have 3 valence electrons. So boron, aluminum, gallium, and indium are all there. They look similar and have similar properties as well, which is what was found with periodic law. Group 14 is the carbon family. So carbon is unique in that it can be found in multiple different states. So graphite is made of pure carbon, and diamonds are also made of pure carbon. The difference between the two is you can break and destroy and crush graphite, and diamonds, a little bit different story. So depending on how the bonds are set up depends on what it is. Silicon, so carbon is a nonmetal. Silicon is a metalloid, meaning it's got properties of metals and nonmetals. And then as you go down, you get to tin and lead, which are both, as you know, metals. So the carbon family, group 14, has all 3 types of elements, being metals, nonmetals, and metalloids. Group 15, the nitrogen family, is another example where you have all three types. So nitrogen is a nonmetal and it's a colorless gas. And then as you go down, you get to phosphorus and arsenic. So phosphorus is a nonmetal, arsenic is a metalloid or a semi-metal, and then antimony and bismuth are both metals. So you have all three types there as well. Your chalcogens. This is a name that's not used very often. It's known as the oxygen family. But group 16, oxygen is the main element there. The most abundant element on Earth. Of all the elements, oxygen is the most abundant. It's found in the atmosphere, it's found in the crust, it's found in our bodies, found all over the place. It is a diatomic gas. So when we talk diatomic means found in pairs. It actually, di means two and atomic refers to atoms. So diatomic literally means two atoms, but found in pairs. So oxygen, when we talk about oxygen gas, we are talking about O2. Two oxygen atoms bonded together, two atomic atoms, two atoms there. So this is the diatomic gas inhaled by human body. This will combine with most metals and form oxides. So you have calcium oxide, aluminum oxide, iron oxide. When they do this, an oxide is more commonly known as rust. So iron oxide is rusted iron. And then oxygen combines with hydrogen to form water, and that is what most of the planet's made of. It's what most of our bodies are made of, and helps us supply us with energy. We also have sulfur in group 16. It is a non-metal solid. It makes the rubber less brittle. It's got a yellowish substance. Sulfur really stinks as well. So if you've been to Yellowstone, the smell you get when you're around the hot springs is sulfur. And then we have these two, tellurium and polonium. Tellurium is a metalloid, and polonium is a metal, and these are relatively scarce, not used very often, not seen very often. So oxygen and sulfur are the two main elements that we work with in column 16. Group 17, the halogen family. So these guys, some unique traits about them. One, they're all diatomic. So again, di means two, atomic means atom. So these are all found in pairs. So fluorine, chlorine, bromine, and iodine are all found as diatomic elements. They're all nonmetals. They're all colored. So this is a very colorful group. Fluorine and chlorine are gases. Bromine is a liquid at room temperature. And iodine is actually a solid at room temperature. So this is kind of unique. You have gases, you have one of the two liquids on the periodic table at room temperature, and you have a solid, all in the same family. But they are all found here because they have 7 valence electrons, and they are highly reactive. That is the reason they're diatomic, is they are highly reactive and don't want to be alone. Group 18, the last column we're going to talk about, is called the noble gases. These are monatomic. So diatomic means two atoms. Mon refers to mono, which means one atom. These are found alone in nature. So we can have just a neon atom. I can have just a helium atom. I can have just a krypton atom. I can have a xenon atom. These are comfortable being by themselves. They're very chemically unreactive. So they have a lack of chemical reactivity. So helium is used to lift different things such as balloons and ships because it is less dense than air. So helium floats on air essentially. Argon is used in different lamps and incandescent bulbs, so it glows and shines. Neon, you think of a neon light, a neon lamp. We're going to look at neon when we talk. We did look at neon when we looked at our light in our system there, the light tubes. Neon is actually orange. So if you see a green light and someone says, look at that neon light, it's actually not neon. Neon is orange, it's not green. Xenon is blue, and radon is reactive. This one is radioactive as well. It is radioactive, and that's the one that breaks down. So this is where we get radon poisoning and things like that. So one of the isotopes of radon is radioactive. Others are okay. The big group in the middle we skipped are called the transition elements. These are in the center, so groups 3 through 12. In general, they have very unpredictable behavior as far as columns go. They're not easy to work with. They have elements or electrons in the d orbital, which can be gained and lost. So these guys have multiple, we call them valence states, multiple charges. So for example, iron can form a charge of +2, or iron can form a charge of +3. Gold can be +1, or gold can be +2. Manganese has like 4 valence states. So it all depends. But that is your transition elements in the middle. Your inner transition elements are down below. That little piece that's cut out at the bottom of the periodic table. The top row is called the lanthanides because it is pulled from lanthanum as the element. And the second row is called the actinides because it's pulled from actinum, which is the element. These are very similar. It's hard to tell them apart as far as chemical reactivity goes. But one important thing is any element that's bigger than number 92. So 92 is uranium. Uranium is the largest naturally occurring element. Everything bigger than that is synthetic or man-made. Large naturally occurring element. So everything larger than 92 is synthetic or man-made, made in the lab. These are some properties of metals. So if you're talking metals, some ways you can describe them. One, they're usually solid. We have one exception, and that's mercury, but everything else is a solid at room temperature. They have between 1 and 4 valence electrons. Again, it all becomes fuzzy when we talk about the transition metals. And they form cations. So they lose their electrons to form a positive charge. They tend to have a very high density. They tend to be silvery in color. Obviously, you have gold, you have copper that aren't silver, but tend to be silvery in color. They're good conductors, meaning they allow electricity and heat to pass through. They are ductile. Ductile means they can be pulled into wire. So copper wire, copper is very ductile, and we use it because it is ductile, so it can be pulled into wire, and it's a good conductor, which is what we want in our walls for electricity. Shiny luster. Luster refers to how it sparkles or how it shines when light is shown on it. So shiny luster as opposed to a dull luster, which we'll talk about. And then they are malleable. This means they can be pounded into sheets, pounded or rolled into sheets. So for example, we talked about Rutherford's gold foil experiment. He's gold because gold is extremely malleable. He can pound it, roll it into sheets, make it very, very thin, and that's a characteristic of all metals. If we're talking nonmetals, they can be all states. So again, metals are mostly solids. Nonmetals can be gases. They can be solids. They can be liquids. They have between 4 and 8 valence electrons, and they form anions, meaning they gain electrons to become negatively charged because the goal is to get to 8. Is to have 8 valence electrons. That's the goal. Whoops, 2 L's. That's all right. They can be all colors. Again, they're halogens, have all sorts of colors. They're low density, most of them being gases, so they float. They're brittle, so your metals are malleable and ductile. Nonmetals are not that. You can't pull a nonmetal into a wire. You can't pound it into a sheet. It's going to break. We call that brittle, so it's going to fall apart. A dull luster, so you shine light on it, it's not going to sparkle and shine like a metal will, so it's dull. And it's a poor conductor, which makes it the opposite of conductor is an insulator. So they are good insulators. But those are characteristics of nonmetals. I would like you to take some time and answer these questions. So I want to know what is unique about alkaline metals, what's unique about alkaline earth metals, what about noble gases, what about halogens, and what about transition metals. And then be able to state a couple differences between metals and nonmetals, as you'll need to be able to distinguish the difference between those when we talk about them in class. Thank you for your time and attention. Enjoy the rest of your day. I look forward to working through the rest of this unit with you.